good. Do you know how to do this? Good. You should have added 84 to your numerator, 100 to your denominator, divide it. Later, when you do that on your own grade, like let's say you made a 96 on your test. Now at the bottom of your grade printout, it has it categorized, like here's what you made out of whatever on homework and quiz and test and project. You'll need to add up that column. That'll give you your total points. Add the 100 for your test. Same thing to your numerator. You'll do it all the same way, except when you're done, and let's say you get 0.964, okay, so that'd be like a 96%. Go ahead and add your own 3-point curve in there. I did it on your paper, but when you put your test grade in there, you know, it's not going to have your 3-point curve in there, so you'll have to re-put it in yourself. Okay, today is the first day of the end of the year. We're going to start doing mini lessons where I give you very, very quick overviews, give you a few problems from them, and then I give you some review work too. What I'm also going to do periodically is I'm going to throw in like one little bitty small section worth of problems. Something that I want you to go back and have to look in your book to figure out how to do. Now, it's always going to be something that revolves around like one thing so that you're not searching for a whole bunch of stuff. You know what? It'll be more obvious to you when I get there. So let's just keep going. You have one, and I'm going to decide when you get it. What? No, you're turning all this in. In fact, the entire last mini-quarter grade is going to be all these assignments. I may have a quiz in there somewhere, but we're not having a test again until the final. And this test is going on, obviously, this grading period. So these homeworks will make up every bit of your grade. If you don't turn one in, that's going to take you down like 5 to 10% because there's no test grade to dilute it now. Okay, exponential functions. This is section 3.1. Are very, 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 very simple. This whole first slide, you can literally punch straight into the calculator. Literally. So like, that's right. 2 raised, oh, I have it right here. Look, I was doing these last blocks. 2 to the 3.4, plug it in. There's your answer. E is right above your division symbol. It's second divide. E to the 2.3 is right here, which spawns the question last block. What is E? Well, E is just a number. It's like pi. It's used in physics and accounting and stuff. And if you're curious, that's E. But anyway, all of these you can punch straight into the calculator. Yeah, in fact, what I'm going to give you to do at the end of this on your own is accounting and using E. I don't know how. It's not my area. But question on this first slide. Does somebody want to see one of those punched in? Number 9. Sure. Second E. Actually, someone told me last block, I've never used this button before, that if you use the one above natural log, it already brings up the exponent. Raised to the negative 0.95. I get 0.38. Good. Next slide. Now, these, you can just sketch them. I want you to graph. You can just sketch them. Here's the thing about exponential functions. What is 4 to the x? That's like taking a number and multiplying it by 4 over and over and over and over and over again. 4 times 4 times 4 times 4. And it's going to get so big so fast. Exponential functions with a base greater than 1 just shoot off to infinity really, really quickly. What's that? Yeah. Yeah. And does anybody remember what negative exponents do? That's right. It puts them in the denominator, which means because you're going to graph this, we're going to graph this on our calculator in just a second, but I want you to know what to expect. On the right hand of the x-axis, it's just going to shoot off to infinity real quick. Because the more times you multiply by 4, the ginormouser your number is going to get. But to the left of the axis, you're going to be dividing by bigger and bigger and bigger numbers. Which means it's actually going to pretty much, you're not going to be able to see it. It's going to be hugging that x-axis because it's pretty much going to be 0. Now let's actually graph it and you can see it for yourself. And all I want you to do on your paper today is sketch these. So this is 4 to the x, graph, bang. It's there, it's just so small you can't even see it, and then whoop, real quick it takes off. What do you think this one's going to look like? Compared to that one, what do you think it's going to look like?
Don't know that line.
Yes, you're all right. No, it's not going to. This is still a number greater than 1. It's still going to shoot off, but it's going to shoot off much slower because 1.5 isn't as big as. So it's going to come out and go up like this. I'll punch it in for you and show you. Okay. Oh, just kidding. Yeah, I forgot the power button. There you go. That first one's 4 to the x, and there's 3 halves to the x. What do you think that one's going to do? Ricky, you said this a second ago. What do you think this one's going to do? Number 15. It is going to be the opposite. Because fractions are just the opposite of whole numbers. You divide them by numbers, they get bigger. You multiply them by numbers, they get smaller. 1/2 times a half times a half is 1/16. But 1/2 divided by a big number is like 50 billion. So, let's look at that on its own line. It's going to be, dang it. No. It's going to be just the opposite, coming from the other direction. And you can probably guess that 17 is going to be pretty much that exact same thing, but once again, exactly, it's a little tad wider. Well, these are, I mean, if you think about it, x is negative and positive. These are the negatives, and these are the positives. So, yeah, this is 1/2 a fraction to a negative exponent. They get real big. Because it's like 1/2 divided by 100. Well, actually, it's 1/2 divided by 1 over 100. Forget it. Anyway, any questions on those about what you're going to be asked to do? The last slide, the only other thing you're going to have today, I want you to get on your own. I will show you briefly what they are. When you go to college, I don't care how good of a student you are, when you go to college, a large part of it, and a lot of people are nervous, like, oh, I'm going to fail out. You won't, as long as you just do what you have to do. There's going to be a lot of times, your professors are going to give you work, and they're going to sound like they're speaking Chinese up there. So, what you're going to have to do is go home, look at the examples in your book, and kind of flip back and forth. Knock it off. You're driving me crazy.
Oh, wait.
What?
You're going to do what I need to do.
Exactly. You're ready for college, Ricky. Everybody should have to go to A school. Okay. Here are the formulas you're going to use. Now, this is in your book. You don't have to write this down. This is literally right before you get into your problems in your book. There's your first equation, there's your second. And it gives you those equations when you use them right above this in the book. And here's an example. Now, your problems are going to look exactly like this. Okay? And you're just going to have to use this example to guide you through that one. For instance, yours, this one, these are accounting things, by the way. You decide to invest $8,000. That's your principal. Goes here. But you'll figure this all out when you're looking at it on your own. For 6 years, that's your time, which goes here. And you have a choice between two accounts. The first pays 7%, which is your rate, which goes here. Compounded monthly. Monthly. How many times a year do you get something compounded monthly? 12, which is the end value that goes here. Or you can take one that pays 6.85%. Oh, but that one actually is okay. I won't get into that right now. Let me ask you this. Monthly would give you a 12 here. What do you think quarterly would give you? 4. If you're doing it 4. What about semi-annually? What do you think that means? Well, it's broken into 2 6-month intervals.
Quarter of a year.
No. God, you guys are being overloading me. No, it's not a leap year. Okay. Quarterly. It is 3 months, but you would still plug in a 4 because it's 4 times you're going to get paid the whole year. That's 3 months.
Every 3 months.
Okay. If it says bi-monthly, what do you think that means? Which means how many times a year? And that's what you'll plug into your n. This is what you're going to have to do. You're going to have to go in your book and you're flip. Example, my problem. Example, my problem. And you're going to have to kind of cut and paste. Now, I've given you some odd problems so that you can check your answers and see if you're doing it correctly. And I advise you to do it like that, or you're going to be up a tree. Good question. That means basically what it really comes into effect is you no longer have an n because it just kind of keeps going. Although technically I think that would be the c, but it doesn't. So that's when you need the second formula. That's the only time you need the second formula. If it says compounded continuously, like instead of it saying yearly or quarterly, if it says continuously, that's when you need that second formula. And you plug things in the exact same way. There you go.